part 1. So this is our week 3 lecture. Can I just confirm whether you can hear me?
Yeah, Miss.
Yes,
We
we can hear you, Miss.
Thank you. All right. So let's begin the class. I'm going to unlock Instat first, and you can sign in. Okay, so I will unlock Instat at the beginning, and then also I'll unlock it again before the class ends. All right, go ahead and mark your attendance. Okay, I hope all of you are doing well. This is week 3 already. We're almost at the end of September. Today is a special celebration if you celebrate the Moon Festival. It's the Mid-Autumn Festival. I hope you have some moon cakes to eat. All right, now let's review. We do some recap of where we stopped last week. So we stopped at this particular slide. Okay, and then unfortunately my computer decided to restart. So we are at this example where we manipulate the surd in order to try to simplify it. So in question C, this example here, right? 5 square root of 6 minus 2 square root of 24 plus square root of 294. So there are 3 different terms with the surd symbol. How can we combine this into a simpler form? Okay, so try to look at the smallest surd value, the square root of 6. Okay, so you use that as your base. All right, so you look at square root of 24, you try to factor it into having one factor as square root 6. Same thing.
Sorry for interrupting. Dr. Maxine, you forgot to record the meeting.
Yeah, this is just reviewing. I will record when I start the lecture. Okay, so square root of 294, we have, again, one factor, which is square root of 6. All right, so you can simplify square root of 4 into 2. Square root of 49 becomes 7. Okay, so you have now 3 terms with square root of 6. Okay, so now you can combine it. 5 minus 4 plus 7. Okay, so 5 minus 4 is 1. 1 plus 7 is 8. So 8 square root 6 is the simple answer. Okay, so when the question asks for the exact values, that means you leave your final answer in square root of 6. Don't convert it into a decimal value. All right, going back to another point. Let's see. Okay. So yes, I also made some error in the last class where we talked about the square root of these numbers. We have square root of 9, so the answer is 3. Okay, so I just want to clarify. Whenever you have a square root function, okay, the answer will always be a positive value. Right? Okay, so if you have any square root function, for example, square root of x, so the answer will always be a positive value. Okay, let's say y equals to square root of x. Why is the answer always positive? If you look at the graph, okay, the graph of y equals square root of x. Okay, so if this is x and this is the y-axis, how will this graph look like? It will look like this. Okay, so y, of course, is a positive value, so x will also be positive values. So any x value will give you a positive y value. Okay, so x will always be a positive value, and likewise y will also be a positive value. All right, so I just wanted to clarify that. And now we are going to continue with this week's lesson. Okay, yes, and I will do the recording. Do you have any questions for me?
No questions.
All good, Miss.
Okay.
No questions, Dr. Maxine.
All right. So let's begin. Okay, so we were talking about the surd symbols earlier. Okay, so this brings us to the next section, which is called rationalizing. Okay, what is the meaning of rationalizing? All right, rationalizing is a process where we have an expression that includes a surd term. And the surd term is in the denominator. Okay, so this, we call it as a rational expression, right? A rational expression is a quotient, is ratio, something divided by something else. So in the denominator, we have a surd term. Okay, so we want to move the surd term to the numerator. Okay, so what is the process of doing that? Okay, so if you have this b, square root b in the denominator, what can you do? Okay, a over square root b. This is an expression. So we can multiply it by 1. Okay, 1 in the form of square root b over square root b. Okay, so this is the process of rationalizing. What happens to your denominator when you multiply square root b with square root b? You obtain b. And then your numerator now becomes a square root b. Right? So now the surd term has moved to the numerator, to the top of the fraction. Okay, so that's the end of the process. So this process is called rationalizing. Okay, let's move to another example. You have a divided by this term b plus square root c. Okay, a, b, and c are real numbers, right? So notice there is a surd term here in the denominator again. So what can you do? Very easy. Okay, you just need to recognize the pattern. Okay, so this term b plus square root c. All right, so again, you multiply this entire rational expression by 1. Okay, you multiply with 1. But this 1 is in the form of b minus square root c divided by b minus square root c. Okay, so notice that here the sign is a plus. So when we multiply it with this, the sign must be a minus. Okay, so we call this b minus square root c as the conjugate of b plus square root c. Okay, so as a result, what do you obtain? Okay, just look at your denominator here. Okay, it's when you have b multiplied by b, okay, b minus square root c. Okay, so here you have a times b minus square root c. Okay, so what happens to the bottom? It becomes b squared minus
C.
You have this c square root c squared, right? So that becomes c. Okay, so notice that the third term goes away. So we have this. Okay, so that's the process of rationalizing. Same thing, okay, with the next one. What do you think? It looks very similar to the previous expression, but now it's b minus square root c. Here was b plus square root c. So what do? Again, you multiply with the conjugate of b minus square root c. Okay, so the conjugate will be b plus square root c. Okay. Let me write it properly. Multiply by 1. 1 is in the form of b plus square root c over b plus square root c. Okay, so just work it out.
Miss? Multiplying by the opposite sign. If it's b plus square root c, why are we multiplying by b minus square root c?
So your question is asking when do you use plus or when do you use minus, is it?
Yeah.
Okay, okay, if you see in your denominator, you have a plus third, okay, plus the third term, right? Then you have to multiply it with the minus of the third term. So we call that as the conjugate. Okay, so here is plus. Here will be minus. You have to multiply with this one. Okay?
Okay, thank you.
Here is minus, then here will be
Plus.
the plus. Yes. Okay, so it's just like saying a plus b multiplied by a minus b. This is your binomial. You are multiplying them, you get a squared minus b squared. So if this is a third term here, by doing this, you actually remove the third term. Okay?
Okay. Yeah. Thank you, miss.
So it becomes like that. All right. Is there any other question from the students here? If not,
excuse me,
right.
Dr. Maxine.
Yes.
Why you are not multiplying a with the bracket of b plus square root c? To simplify more.
I'm sorry. I'm sorry. Can you repeat?
Why you are not multiplying in the last step a with the bracket of b plus square root c?
So this becomes ab plus a square root c? Yes. Yes. I just ran out of space. Sorry. But yes, okay. You should do that. You should do that. Yes, thank you.
You're welcome.
All right, so some simple example. Okay, just erase the screen here. So rationalize the following. Okay, so this following expression, 1 over root 3. So what do you do? See, there's a third 3 here. So you have to multiply it by?
Third 3.
Yeah, third 3 over third 3. So this is 1. Okay, you're multiplying it with 1 in the form of cert3 over cert3. So you get cert3 over 3. Okay, let's move on to the next example. All right, rationalize this expression. So what do? Okay, notice the denominator has 3 plus a cert term. Okay, so it looks like this form. Okay, so how can you remove this cert2 into the numerator?
We multiply by 3 minus cert2.
Yeah. So you multiply by 1, but in the form of 3 minus cert2. Okay. All right, so here you will get 3 minus cert2 over, so 3 square minus cert2 square. So it becomes 9 minus 2. Okay. Okay, any doubts here about this?
Dr. Maxim.
Yes.
So for operation involving cert, so we must rationalize our final answer, right?
Yeah, usually we want to have the cert term in the numerator. So the way to do this is by rationalizing it, by multiplying with the correct multiplier. Okay.
Okay, thank you.
All right. So the next one, okay, this is the full solution. It's in your slides. Okay. So the next one, all right, I want to see your solution. So I'm going to just change my screen. All right. Okay, so please go to this link, the whiteboard.v. Okay, so please click on the link in your chat box, and that should bring you to this. Oops. Okay, good. I see you are all joining. Very good. So once I see everybody has joined, then I will push my whiteboard to you. Okay, any more? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I hope everybody is in. All right, so now I'm going to push this whiteboard. So you can show your solution on how you rationalize this expression. Okay, the numerator has √5 plus √2. Denominator is √5 minus √2. Okay, so what do? There are cert terms at the top and the bottom. Okay, so what do you do? Try to write your answer instead of typing it. All right, I think most of you got it. Okay, so what solution should you get? Okay, let's see. So I hope you have completed the rationalizing, right? So when they say rationalize, okay, rationalize here means that we want to remove any surd terms which exist in a denominator. So there's one surd term here, there's another surd term. So we want to get rid of that. So we just focus on the denominator first, right? So we have to multiply it with 1. Okay, we multiply it with 1, but 1 is in the form of the conjugate of this denominator. So conjugate will be square root of 5 plus square root 2. Okay, so the top will also be the same, square root 5 plus square root 2. Okay, so then your denominator becomes 5 minus 2, right? What happens to the top? Okay, you have again square root 5 plus square root 2 square. Okay, I'm sure you already know this. When you expand, okay, your a plus b, you get a square plus 2ab plus b square. So we're doing the same thing here on the numerator. Okay, so you get 2 square root 5 square root 2. Okay, so just tidy it up. 5 plus 2 plus 2 square root 10 is your numerator, and the bottom you have 5 minus 2. Okay, so this will be 3, this will be 7 plus 2 square root 10. Okay, did you get this answer?
Yes.
All right, so I hope all of you are able to get it. All right. No, not everyone got it. So please take a look where you went wrong. Huh? Most got it. Okay, so you can take a snapshot of this solution and then try and do it again in after this lesson. Okay.
Miss, when will we know? Sorry for interrupting.
No problem.
When will we know if we have to like remove the fraction? Like when will we know if it's not like in the fraction form?
Sorry, it's not in a fraction form. If it's not in a fraction form, that is not a rational expression. So you don't have to do any rationalizing. So this rationalizing is only used when you have a fraction. You have something dividing something else. And then at the bottom of this fraction, you have some third terms. Then you want to remove the third term from the bottom of the fraction. So you go through this process. If you are not dealing with a fraction, then you don't have to do this. Is that clear?
Yes, thank you.
All right, so let's.
Miss?
Yes, go ahead. Yes.
Why does the top, when it gets squared, it enters a square plus 2ab plus b square, but the bottom is just a square and square?
Okay. All right, thanks for your question. So the bottom here, okay, the bottom here, you notice it's, let me try and write. A minus b times a plus b, right? It's the form of a minus b and times a plus b, right? A is root 5, b is root 2, all right? So what happens when you multiply these two? We call it a binomial. What do you get? You get a square, right? You can multiply like this, a square, and then you multiply with this, you get plus ab, and then multiply this with this, you get minus ab, and then finally b and b, you multiply them. Negative b times positive b, so you get negative b squared. So these two, ab minus ab, they cancel off, so you get a square minus b square. So that's how you get root 5 square minus root 2 square.
Okay, thank you, Miss.
You're welcome. All right, thanks for your question. Okay, so let's continue on with the next section. Yeah, still talking about rational expressions. What we dealt with just now was one type of rational expressions which have a third term. Okay, so now let's talk about rational expressions in general. Okay, a rational expression is basically a quotient, a quotient or a ratio. Okay, you have something like A over B. Okay, now of two polynomials. Okay, so we can say this A is a polynomial, B is a polynomial. What do you understand by polynomial? What is a polynomial? Well,
An expression with a lot of terms.
yes, right. We have polynomials. We have one type of polynomial. We have something similar called a monomial. Mono means single or one. Poly means many, right? So an example of a monomial will be like 3x to the power of 4. Okay, so there's only one term. We also have another specific polynomial called a binomial. Okay, like take for example, 2x cubed plus 3. Okay, so there's two terms. One term, second term. So this is called a binomial. Bi means two. Okay, so polynomial means it has many terms. You can come up with another one, trinomial. So how many terms does this have? Tri means 3. So you get 2x cubed plus 3x minus 7. Okay, so 1, 2, 3 terms. So that's a trinomial. So polynomials means having many terms. Okay, so this is one example of a rational expression. 4 divided by x minus 2. Now, one thing about rational expressions is that if there are some unknown x in the denominator, we need to be very careful to state, right, what values of x is valid for the entire expression. Here, x cannot be equal to 2 for this expression 4 over x minus 2. Okay, x cannot be equal to 2. Why? Why must we state this exclusion? X cannot be equal to 2, because if x is equals to 2, then the denominator becomes 0. So we cannot have 4 divided by 0. Okay, so this is undefined mathematically. We cannot divide a number by 0. Okay, so therefore, whenever you have some x term in the denominator, you must state, right, explicitly. Okay, what is the set of real numbers, right, for which this expression, okay, this is the domain. What is the set of numbers which is defined? Then if there's any number which is not in, you have to exclude it. Okay, must exclude numbers from the domain that makes the denominator 0. Is that clear? Do you understand?
Yes, Miss.
Okay, good. Let's continue with another example. So see here we have x over x squared minus 1. All right, now here we cannot directly define the domain for this expression yet, okay, because we have x squared. So what we can do now is to factor this x squared minus 1 polynomial. So we factor it into x plus 1, x minus 1. Then only we can see, x cannot be equal to negative 1. X also cannot be equal to positive 1. Okay, that's why we have to write this exclusion. Can x be equal to 0? Can this become 0? Can. You can have 0 dividing by a real number. No problem. But you cannot have a 0 at the bottom. Okay, so always remember to write out the set of the real numbers. Okay, so this is a real world example here. This is a real world example. The cost, right? What is the amount of money in terms of millions of US dollar to remove the X% of pollutants from a river? Okay, so X is the percentage of pollutants, right? So the cost of cleaning up the river, the cost of removing the pollutants is given by this expression. Okay, is in million USD. So 250x over 100 minus x. So let's say if you want to remove, if x equals 100, that means you want to remove 100% of pollutants from a river. What will be the cost? If x equals 100.
Undefined.
Yeah, it's undefined. In fact, it's astronomical, I would say. It is impossible to totally clean up a river from pollutants, unfortunately. Okay, now let's move on to some exercises. So the next set of exercises involve simplifying rational expressions. Okay, we will deal with simplifying them. We'll deal with multiplying and dividing rational expressions. So there are some recommended guidelines to do this. Okay, so when we simplify rational expressions, right, if the numerator and denominator are not factored, they are not in a factored form. For example, this one is not factorized. So we need to factor both the numerator and the denominator completely. Okay, so there are a few reasons why we want to factorize it. Okay, first of all, it helps us to exclude numbers from the expression's domain, which would make the denominator 0. Okay, so in this case, you can see this is already in a factored form. So you can easily see that x cannot be equal to -1, right? But here, you can't say what is the exclusion yet, right? You need to factorize it. Okay, then only you can say what are the set of real numbers which is valid for this expression. Okay, so first of all, factor, then write out the exclusion. Finally, okay, if there are any common factors, then you cancel them off. Okay, you cancel them off by dividing both from the numerator and the denominator. Okay, so these are the recommended guidelines. All right, so let's take a look at number 1. Okay, so you have x cubed plus x squared divided by x plus 1. So how to simplify this? Okay, first step tells us to factor. Okay, so we can factor the numerator. X squared is a common factor. Okay, then you have x plus 1. Okay, and then the denominator, you also have x plus 1. Right? The second step says exclude numbers which makes the denominator 0. Right? So here, x cannot be equal to -1, because if x equals -1, we are dividing by 0. Okay, third step, cancel off any common factors. So what are the common factors? At the top and bottom, x plus 1 is the common factor, so we divide. Okay, we divide by x plus 1 here and here. So you end up with this answer, x squared. Okay, and x cannot be equal to -1. All right, so this is the entire process of simplifying this particular rational expression. Any questions here?
No questions.
No question, Dr. Maxine.
Thanks for your response. Okay, if no questions, let's move on to the second question. Okay, so first step, factorize the numerator. You can also factorize the denominator. Okay, here I think it's relatively easy. X plus 5, x minus 5. All right. Anybody not sure where we got this? X plus 5, x minus 5? Okay, refresh your mind. Just now we were talking about multiplying the a plus b, a minus b. So this becomes a squared minus b squared. So this is just the reverse of doing that. Okay. What about the numerator? Can you factor it?
Yes.
It's a quadratic. It's a quadratic expression, so you can. So you have x. Okay. 1 and 5. Right? You can have x plus 1, x plus 5. Okay? So I'm sure you can do it faster than me. Okay, so now that you have factorized the numerator and the denominator completely, you move to step 2, excluding any number from this rational expressions domain, which will make the denominator become 0. So x cannot be equal to plus or minus 5, right? So now moving on to step 3, okay? Are there any common factors in the numerator and the denominator? If yes, cancel them off. Okay, that's x plus 5 in the numerator and the denominator. Okay, so cancel off. So that leaves us with x plus 1 over x minus 5. Okay, and that is our domain. X can be any real numbers except plus 5 and negative 5. Okay, so now please try number 3 and number 4. Again, you can go back to the whiteboard. I hope you are still connected to the whiteboard. Okay, so now I will push this to you. Okay, so try and work it out. It's the same question as in the slides. Okay, simplify these rational expressions. Okay, so remember the step. First step, you must factorize the top and the bottom. Second step, are there any excluded values? Okay, we don't want the denominator to become 0. Third step, cancel off any common factors. Okay. So try and do it. If you got disconnected, okay, just try doing it on paper. Okay, I'll give you a couple of minutes. Remember to write out the set of real numbers, okay? Most of you managed to simplify, but don't forget to write out x cannot be what value. Okay. All right, so now let's see if you obtain the same answer as me. Number 3. You have x cubed plus 3x squared in the numerator. So let's write. Okay. So let's factorize x squared, x plus 3. Okay. And then at the bottom, you also have x plus 3. All right. And then before you start canceling off these factors here in the numerator and denominator, make sure you write out, okay, what's the excluded x from the domain. X cannot be equal to -3. Then only you cancel. So your answer is x squared. Okay. Your answer must include this. Then only the entire solution is correct. Don't just stop here. You must also have this. Number 4. Okay. X squared minus 1. So you can take this 1 as 1 square. Okay. Then you can factorize the top. So you have x plus 1, x minus 1. At the bottom, okay, you can also factorize it into 2 factors. For this quadratic expression, you have x plus 1 and another x plus 1. Okay, you just check. Yes, when you expand it back, you should get this. Okay, don't cancel off yet. Don't cancel off yet. Make sure you write down any exclusions. X cannot be equal to -1. So you write out the domain for this expression. Okay, so this is the final answer. Okay, after you cancel off, then you can get this answer. Did you all get the solution? If not, please check where you went wrong. Okay. Should we take a short break right now? Do you want to take a short break or can we continue?
Yes, please.
Short break, okay. 3:47. Can you come back in 10 minutes? Okay, by about 3:57.
Yes, thank you, Miss.
Okay.
Thank you, Miss.
See you in a short while.
Thank you, Miss.
Come back,
Okay, Miss.
All right. Hi, welcome back to the class. I have just unlocked Instat, so for those who haven't got a chance to take your attendance yet, please do so now. Okay, great, thank you. All right, now let's go back to my screen. Okay, so before the break, we were working on simplifying these rational expressions. Okay, and it should be relatively simple as long as you follow the guidelines which are given and you can recall how to do factorization. Okay, these are relatively simple. Let's move on to the next section, multiplying rational expressions. Okay, so it's very similar, yeah. Now, instead of having just one single rational expression, now you want to multiply. Again, after you perform multiplication, you still need to simplify. The steps are repeating, as what we did in the previous section. So when we are multiplying rational expressions, okay, step 1, factoring all the numerators and denominators completely. Similar. Step 2, look at the domain of the expression. Exclude any number which makes the denominator 0. Okay, so always focus on the denominator. Now, after that, you can cancel off the common factors. Okay, the steps are similar. After doing so, then you can continue to multiply any remaining factors in the numerators as well as multiply all the remaining factors in the denominators. So this step 4 means that we want to have a polynomial. Okay, numerator and a polynomial denominator. Okay, so let's take a look at these two short exercise here. Okay, multiply this expression with this expression. Okay, so what's the first thing? Factor. Okay, factor all the numerators and denominators completely. Okay, so this just means, okay, the first set is already factorized. The second one, okay, so you need to factorize the second rational expression. So the first one, I'll just rewrite it. It's the second one. So x squared minus 1 becomes x plus 1, x minus 1. The denominator, you have 3x minus 21. So can you factorize that? Yeah, 3 is the common factor. X minus 7. Okay, so now that you have factorized it, go to step 2. Exclude the numbers from the domain which makes the denominator 0. So what are the exclusions? X cannot be equal to 1. And here, x cannot be equal to 7. Okay, so you can just write at the bottom, x cannot be equal to 1. X cannot be equal to 7. Okay, now go to step 3. Okay, if there are any common factors at the top and the bottom, just cancel them off. Okay, so now x minus 7 here, you can cancel off with this. You have x minus 1 on top and x minus 1 at the bottom. Again, you cancel off. So now you are left with x plus 1 over 3. Okay, and the exclusion x cannot be 1, x cannot be 7. Okay, so this is the full answer. Oops. Any questions? Is it clear?
Yes, Miss.
Okay, great. Let's continue to the number 2. What can we do here? Again, you factorize. Okay, factor x plus 3. Nothing to be done here, but the bottom, you can factor it into x plus 2, x minus 2. Okay. Okay, multiply with the second fraction. X squared minus x minus 6. Can you factorize that? Can you tell me what are the two factors?
X minus 3 and x plus 2.
X minus 3, x plus 2. Can anyone else confirm that? Yes, that's right. That's right. What about the denominator? What are the two factors?
X plus
X
3,
plus
x
3,
plus
x
3.
plus 3.
X plus 3. And what's the second one? Also?
X plus 3.
Yes, thank you. All right. What's the next step? Do we straight away cancel off the common factors? No, write out the exclusion first. So here, x cannot be equal to what numbers? Can you tell me? What are the exclusions for the domain?
-3 and plus minus 2.
Yes. So x cannot be equal to -3, +2, and -2. Okay, so now we can go ahead and cancel off the common factors. Okay, x plus 3, x plus 3. Is there an x minus 3 at the bottom? No. X plus 2, x plus 2. Okay, so now we have simplified. Okay, you have x minus 2, x plus 3 in the denominator. Okay, do we stop here? No, there's one more step. Okay, all right. Expand the denominator. Okay, so this becomes x squared plus x minus 6, right? Okay, so this is the answer with this exclusion. Okay, so you must write out in full. Okay, now we move from multiplying rational expressions into dividing. So the steps are also very similar. Okay, so you see some example questions here. Instead of multiply, we have divide. So normally when you see divisions written out like this, what can you do? You straight away convert this into, you invert it. Okay, so you invert the divisor and you change the sign to multiply. So this becomes x plus 3 divided by x minus 4. Okay, so this term becomes multiplying of this term. Okay, so that is the first step. Okay, change the sign to multiply. After that, the steps are all as before. Okay, so let's go into the whiteboard again. I have just one more for you to try. Are you still in the whiteboard? If not, you try to enter again. Yeah, I think a lot of you are already disconnected. So you can use the room code again. I put it in the chat box, so you join again. Okay. Any questions? No. Okay. All right. So just go back to the whiteboard, and then I will push the next set of questions to you. This one we've just done. Okay, let's try dividing this. Okay. Okay, so this is question 2 from the slide. Okay, so once you see your whiteboard refreshed, then you can start to solve. Okay, so when we are dealing with dividing rational expressions, you look at the divider sign here. Okay, divide, you convert it into multiply, and then the rational expression will be inversed. Okay, you take the reciprocal. All right, so please go ahead, try it out. Okay, I'll give you 2 minutes. When you are writing out the exclusion for the domain, just make sure you don't cancel off any common factors first. Always write out the exclusions, then only do the cancellation. Because if you do cancel off, then whatever factor is left behind is not fully representing the original expression. Okay, all right, so I think some of you have gotten the solution. Okay, so let's see. Right, I will choose blue. Okay. All right, so here I'm going to do the first step in dividing this rational expression. I'm going to inverse this. Okay, 3x squared plus 3 over x squared plus x minus 2. Okay, so you take care of this divider sign first, dividing sign. Okay, so once you've done that, then factorize the numerator and the denominator. Okay, so x squared minus 2x will be x done. I think you can have minus 1. Okay. Okay, so let's check that our factoring is correct. Okay, x cubed plus x squared plus 2x plus x. Okay, so all right, now that we've come to this part, we need to write out the exclusion. Don't go on to cancelling first. So here x cannot be equal to 0. Okay, x cannot be equal to 1 and negative 2. Right? Then you can proceed to cancel off. Okay. Any comments?
No comments.
Okay. What about negative 1? Okay. I got a comment. If x equals to, let me check the chat box. I saw a question. Okay, that's a personal. Okay, Dr. Maxine, what about negative 1? All right, if x equals to negative 1, so then x squared becomes 1, right? Any? Okay, so no need to write the exclusion like x cannot be negative 1. It's fine. Okay, so there are 3 excluded numbers here. Okay, yeah, there was a personal question coming in. Okay, so I hope it's clear. Let's continue. All right, now the last few slides is about adding and subtracting rational expressions. Okay, so if you have done this before in your high school, so again, this will be a revision for you. Okay, now there are two situations when you are either adding or subtracting rational expressions. If the denominator is the same, then it's very straightforward. Okay, you can go right ahead and add or subtract the numerator. Okay, if the denominator is the same, then you can just directly add or subtract the top, the numerator. At the same time, remember to write out the exclusion. Okay, here b cannot be equal to 0. Okay, very straightforward. What about if the denominators are different? If that's the case, you have b here, you have d here, then you need to do cross multiplication. You need to have a common denominator. Okay, all right, so when you have different denominators, okay, and they have several common factors, the most efficient way to combine them is to find the least common denominator. Okay, what is this LCD or least common denominator? Right, so this LCD is a polynomial which consists of the product of all the prime factors in the denominators. And each factor, we just raise it to the greatest power of its occurrence in any denominator. Okay, that sounds like a very long sentence, okay, with a lot of big words. So let's take a look at some examples right away. Okay, so I have one example which uses the least common denominators. Okay, now first of all, let's look at this question. X plus 2 over 2x minus 3 minus 4 over x plus 3. Okay, so straight away we're going into different denominators. All right, what do we do in this case? Okay, so it's considering like a over b minus c over d. So what do you do in this case? You have to combine the bottom, right? So you have b and d as a factor. So at the top, you have AD. At the minus BC. Okay, and then B cannot be 0. D also cannot be 0. Right, so we use this as a guide. Okay, so here we write out the factors in the bottom. 2x minus 3 and x plus 3. Okay, so at the top you have x plus 2, okay, multiply with x plus 3. Okay, and now minus the BC. So BC will be 4 times 2x minus 3. Okay, just extend the line. Okay, so this is exactly the same thing as this. All right. So now go ahead and expand the top, all right, the numerator. You can go ahead and expand. So x plus 2 multiply x plus 3, you have x squared. And then 2x and 3x, that becomes 5x. Okay, 2 times 3, you get 6. Okay, minus, okay, 4 into 2x, so 8x. Minus 4 times minus 3 becomes plus 12. Okay, so Denominator, you just remain as is. Why? Because we want to write out the exclusion. What is the exclusion here? Can you tell me x cannot be what? Look at the denominator. X cannot take on two particular values. What are they?
3/2 and -3.
Yes, x cannot be -3 and 3/2. How do you get the 3/2? Okay, you just take a look at this. Okay, 2x minus 3, if it equals 0. 2x, you solve for x. 2x equals to 3. And then you divide by 2. X equals 3/2. So here, x cannot be equal to 3/2. Okay, that's how you get the value x cannot be 3/2. You take the factor, equate it to 0, then you find x is 3/2. Okay. Now, for the top, you tidy up. Okay, x squared. Okay, you collect all the like terms, 5x and -8x. So you have -3x. 6 and 12. 6 plus 12 is 18. Okay. So now this is the final the final part for the numerator. For the denominator, you need to multiply it. You need to multiply it out, expand it out. So 2x times x is 2x squared. Okay, then 6x minus 3x is 3x. -3 times +3 is -9. Yeah. Okay. Okay, so there we go. I just write it nicely. Okay, so this is the full answer. Okay, so you have to write the top and bottom in the form of a polynomial, and then what are the excluded values for x in the domain?
I think it's positive 3/2, isn't it?
A mistake. Okay. All right. Any question on this? I hope it's clear. All right. Question number 2 is also very straightforward. You can go ahead and try that. I want to go to the next question, which uses this least common denominator. Okay, what does that mean? All right, take a look at number 3. X plus 3 over x squared plus x minus 2. Okay, this is the first fraction plus the second fraction, 2 over x squared minus 1. Okay, now how do you combine these two into a single fraction? Okay, go ahead and, okay, tell me what do you think? Shall we go ahead and multiply it straight away? Let's say, okay, this is A, this is B, so we get AB. No, there's another way, all right? If you look at this denominator here, can it be factored? Yeah, it's possible to factor the denominator. Okay, so you have x plus 2.
X minus
1. Yeah. Okay, plus 2 over, okay, x squared minus 1, again, you try to factor it. So x plus 1, x minus 1. Okay, so notice that there are factors in your denominator. So What is LCD? Okay. You have 1, 2, 3, 4 factors here, but x plus 2 is only is one of the least common denominator because it's only in one of the fraction. Okay, so you have x plus 2. Okay. X plus 1 is also a least common denominator. Okay. Now, x minus 1 and x minus 1, they exist on both fractions. So you only take one of it. Okay, so you have 1, 2, and these 3 factors. Okay. Any repeated factor, you don't take it. Okay, you only take it the one time. All right, so that when you combine, okay, you have x plus 2, you have x minus 1, and you have x plus 1. Okay, you look at the top now. Okay, so your x plus 3 was there in the beginning. So now you must multiply with what factor? Okay, x plus 3 over x plus 2 and x minus 1. Okay, so these two were there originally. This one was not there. So now you have to multiply x plus 1. Okay, now go to the plus sign. Okay, plus 2. Okay, so initially it was 2 divided by x plus 1, x minus 1. So now x plus 1 is there, x minus 1 is there, x plus 2 is not there. So you must write x plus 2 here. Okay, this is a much more efficient way than trying to multiply this with this. Then you end up to x to the power of 4. Okay, no need. Right, so use the least common denominator method, and then now you can expand the top. Okay, so you have x plus 3 multiply x plus 1. That gives you x squared plus 4x, right, plus 4. Okay, please check me as I'm doing. Okay, now plus 2 times x plus 2. So 2x plus 4. Okay. The bottom, you just leave it in the factored form first. Okay. Why? Because we want to write out the exclusion. X cannot be 3 values. X cannot be -2 and plus minus 1. Okay, now tidy up the top. X squared plus 6x plus 8. Okay, did I do? Oh, sorry, I did something wrong. Here is 3. Okay, so here will be 7. Okay. Now the bottom, remember I have to expand it to become a polynomial. So I have x plus 2, x squared minus 1. So I should write in the next line, okay, but I don't have space, so I just write to the right. So x squared plus 6x plus 7, okay. I expand this further. Okay. Right, so you should have x cubed minus x plus 2x squared minus 2, okay, as your solution. All right, so we stop here for today. Sorry, I overshot the time. All right. Thanks, class. Bye.
Thank you,
Miss.
Thank you. Bye-bye.
Thank you, miss.
Thank you,
Thank you so much.
miss. Thank you.
Thanks so much, Miss.
Thank you, miss.